Greetings to all. This is Vaishnavi, Assistant Professor IT Department from SNS College of Engineering. Now we are going to see about the inter-process communication in operating systems. First one, inter-process communication. Inter-process communication is used by cooperating process to communicate each other. Inter-process communication is the best provided by message passing system. Here we have the two models of inter-process communication. First one is the shared memory, second one is message passing. Here we have the diagrammatic representation of the shared memory and the message passing. Here we have that first for the first one, shared memory, process one shared the memory. Next process two, it shared the memory. For the message passing, process one, process A and the process B, we have the separate memory and it interconnected through that kernel. Next one is inter-process communication, shared memory, an area of the memory shared among the processes that wish to communicate. The communication is under the control of the user processes, not the operating systems. Major issue is to provide the mechanism that will allow the user processes to synchronize their actions when they access the shared memory. Next type is inter-process communication, message passing, mechanism for the processes to communicate and to synchronize their actions. That is message system. Processes communicate with each other and resorting to shared variables. Next one, inter-process communication facility provides a two operation, that is send the message and the receive the message. The message size is either fixed or variable. If the processes P and the Q want to communicate, they must send the message to or receive the message from each other. The communication link must be accessed between them. Next, we have the several methods for logically implementing a link and the send or the receive operations. That is, we have that five methods. First one, direct or the indirect communication. Second one, symmetric or the asymmetric communication. Third one, automatic or the explicit buffering. Fourth one, send by copy or the send by reference. Fifth one, fixed size or the variable sized messages. Next one, direct communication. Processes must name each other explicitly. That is send the message. That is P comma message. That is processor P comma message. Next one, receive Q comma message. Receives a message from process Q. Properties of the communication link. Links are established automatically. The link is associated with exactly one pair of communicating process. Next one, between the each pair there exists exactly one link. The link must be unidirectional, but it is usually bidirectional. Next one is indirect communication. Messages are directed and received from the mailboxes. It is also referred to as ports. Each mailbox has its unique ID and processes can communicate only if they share the mailbox. Next one, primitives are defined as send and the receive. That is a comma message. Receive here we have a comma message. That is send a message to mailbox A and receive the message from mailbox A. Here we have the properties of the communication link. That is, link is established only if the processes share the common mailbox. Next one, a link may be associated with many processes and then each pair of processes may share the several communication link. Fourth one, link may be unidirectional or the bidirectional. Next topic is synchronization. Message passing may be either blocking or non-blocking. Blocking is considered as asynchronous. Non-blocking is considered as asynchronous. Here blocking is considered as synchronous. Here we have the two types, that is blocking send and blocking receive. The sender is blocked until the message is received. Blocking receive, that is the receiver is blocked until the message is available. Next type is asynchronous. Here we have non-blocking send, that is the sender sends the message and continue. Next type is non-blocking receive. The receiver receives a valid message or the null message. Next one is buffering. Messages exchanged by communicating processes reside in the temporary queue. The queue can be implemented in one of three ways, that is zero capacity, bounded capacity or unbounded capacity. First one, zero capacity. Queue has a maximum length of 0, thus the link cannot have any messages waiting in it. The send must be blocked until the recipient receives the message. Second one is bounded capacity. Finite length of n messages. Sender must wait if the link is full. Third one is unbounded capacity, that is infinite length. Sender waits, never waits. Next example of the inter-process communication systems, and that is Windows. A message passing the centric via the advanced local procedure call, that is LPC facility. Once only work between the processes on the same system, uses the portals like mailboxes to establish and maintain the communication channels. Communication works as follows. The client opens the handle to the subsystem's connection port object. The client sends the communication request. The server creates the two private communication ports and returns the handle to one of them to the client. Next one, the client and the server use the corresponding port handle to send the messages and are call back and to listen for replies. Next one, we have the local procedures calls in window. Here we have the diagrammatic representation. Client is connected to the server. Here we have the intermediate of connections port, client communication port, and the server communication port. And last one is shared section object. Thank you.